Oh yes, we've got more integration. We're on question number 5. And here it is. What we've got to do is find the integral of x squared e to the minus x dx. So there it is. Jot that one down, have a quick go, and we'll go through the solutions in a couple of seconds. Righto, it is solution time. So let's get cracking. Now, hopefully you spotted you needed to do integration by parts for this, okay? So the by parts formula, I've put it down here for you. So we're going to be using that. And when you are doing by parts, obviously it's important what you pick as u and what you pick as dv dx. And so if you're ever struggling to remember what to pick as u, you could follow this, late. So what does it stand for? It stands for logs first, right? What does that mean? That means within your integral, if you've got a log, an ln, something like that, you put that as u first, okay? If you do not have logs, don't have ln's, then you put the piece of algebra as u. So that's like x squared or x cubed or something like that, right? In our question here, that's x squared. So we're going to put that as u, okay? Exponentials is last on the list, so do not make that u for this question, okay? So let's just fill this in. We'll have x squared as u, and dv dx would be e to the minus x. There we go. And now what do we need to do? Well, we'll differentiate to get du dx. And for du dx, that's going to be just 2x. And on the other side, we'll need to integrate to get what v is. So if we integrate that, that's going to give us minus e to the minus x. Awesome. So now using the by parts formula here, what do we need to do? We need uv. So that's going to be minus x squared e to the minus x. That's uv. Take away the integral of v du dx. So v du dx is going to be minus 2x e to the minus x. And there we go. What I'm going to do is I'm going to take this minus 2 outside of the integral, right? So I'm going to make it this, e to the minus x. And then we'll put out here plus 2. Lots of e to the minus x. So like that. Now, to integrate this in here, we've actually got to do by parts again. Okay, so we'll need to set this all out again on the side. So let's do that now. So we'll have this and this. We'll have u equals something and dv dx equals something. So that's what we start with, right? U is going to equal x again because that's our piece of algebra. Remember, late. Okay, and then e to the minus x. That's dv dx, and we need to find du dx, which is just going to equal 1. And we need to find v, so integrate that, which is going to give us a minus e to the minus x. And there we go. So what have we got now? Well, we've got minus x squared e to the minus x plus 2 lots of, and now we need to apply our by parts formula again. So uv, which will be minus x e to the minus x, subtract the integral of v du dx, which is just minus e to the minus x. There we go. So we'll neaten that up a tiny bit, so that there, plus 2 lots of minus x e to the minus x. This minus here, I'm going to take that outside as well to turn that into a positive, and then e to the minus x. There we go. Okay, let's actually integrate. So now we'll have that there. Keep the 2 on the outside for the time being. X e to the minus x plus, now the integral of e to the minus x is going to be minus e to the minus x. So we've got that there. And now we can multiply that out by 2. So we'll have all of that there. So your minus x squared e to the minus x. Then take away 2 x e to the minus x. And then subtract 2e to the minus x. Pop the c on the end. And there we go. So, good little question there on integration by parts. That's where you had to do it twice, right? So do beware of questions like that. And remember late. Late, very important to help you pick what u is going to be, right? If not, integration by parts can be a little bit tricky. So jot that one down and yeah, keep it handy somewhere so you can check over it just before you do a couple of integration questions. Perfect. another integration problem coming out very soon, so stay tuned and I'll catch you there.